So I'm planning to finish off this serverless section today. There's lots of other services that we won't get to look at, but the one we're going to look at today is called Cognito. So these are the slides, and this is the lab. So where Cognito fits in, it's very much a special purpose service in a way. It deals with user account management, I guess, which is a feature you would have in pretty much every application. And this is a kind of an image that I've shown you before, where we're kind of breaking up your any serverless application up into its kind of logical areas. So where Cognito fits in, it's still, I guess it comes under state management because your user accounts would be part of an application state. So we don't put user account information into a traditional database. We could if we wanted to, if we could grow our own user management, but Cognito is designed for that purpose. And so what it is a service for essentially allowing you to give identities to your individual users. Now, Cognito has two main resources, user pools and identity pools. User pools are what we're interested in, and user pools deals with your kind of conventional user management and the functionality around that. By the functionality, I mean, it handles user registration, sign up, sign in, sign out, those kind of standard behavior. So it has, to a degree, it takes care of all of that. Now you have to write a little bit of Lambda code to trigger that functionality. The identity pool, which we won't look at, identity pools are more concerned with giving users AWS credentials so that they can access some of your AWS resources directly. The simplest example of that would be if you had an S3 bucket and you wanted to allow your users to upload stuff to the bucket. Then that's where that would come in. Now you can use identity pools and user pools in combination, and that might arise in many scenarios where users log in the kind of traditional way, but they also have AWS credentials, which gives them certain permissions over and above the ordinary kind of authentication related permissions. We know about IAM as well from, sorry, no, one sec. Oh, yeah. Well, we know about IAM from before, and you might think that IAM, doesn't that also deal with identity management? And it does, but the kind of difference between Cognito and IAM, a very simple distinction between them is when you've got large volumes of users that you want to give access to your applications, then that's where Cognito comes in. IAM is more for when you've got a small team of users, and tends to be more your kind of development team, I suppose, rather than your end user group. That's a very simple distinction between them. Although, as I said, identity pools are about giving you your typical users some AWS credentials as well. So, it's not a straightforward divide between Cognito and IAM. They do kind of overlap to a certain degree. Anyway, our focus is on Cognito. And as we might expect, it's a serverless service. Yeah, you could think of it as just it manages a database behind the scenes. I don't know if it actually uses a database behind the scenes, but it wouldn't be hard for us to envisage that's what's actually going on internally, even though we don't deal with Cognito in a kind of a database way. And it has all the usual stuff that you'd expect a user management service to provide. Provides simple login functionality. You can specify what attributes a user provides at registration time. We won't go beyond the normal ones of just username and email. You have stuff like password resets, support, email, phone number verification, multi-factor authentication. You can build all of those into your applications as you might expect. Alternatively, if you want to log in using your kind of social media credentials, you can stitch that in as well. We won't go that route though. You can disable users or block them, which you might want to do if a user contacts you and tells you that their credentials have been compromised. And what's the last point? Yeah, it uses JWT tokens a lot, and we'll see that when we walk our way through a simple illustration of using Cognito. And you remember JWT tokens from, you may have come across them in lots of places, but you certainly came across them in the Web App Dev module. This is kind of the big picture view. So Cognito works with API Gateway. They kind of go hand in glove. And so you're still using API Gateway to communicate. Keep losing the mouse for some reason. You're still using API Gateway, doing your sign in, sign out registration. But Gateway talks to Cognito and hands control over to Cognito to do things like verify that the password username combination is correct. It also generates the JWT token, which is what's returned back to your client. And then that token is used for all subsequent requests to authorize the user to access whatever resources are at the back end. And it doesn't have to be Lambdas. It also works with load balancers and other resources as well. This is kind of a drill down into a deeper look at it. Now, what I'm showing you here, you don't have to follow this, but it tends to be a typical design pattern that's used, whereby you actually have two API gateways interfaces to your application. One gateway deals with all authentication related requests. In other words, log in, log out. The other gateway deals with requests to access your backend functionality. And so the flow is, and there's lots of lambdas scattered around here, as you can see. So, your typical flow is your user first logs in. So whatever the URL domain name of this gateway is, and whatever the endpoint is for login, that request goes to this gateway. It uses a Lambda. We have to write the Lambdas, but they're pretty much boilerplate. It uses a Lambda then to actually communicate with Cognito. So Gateway doesn't talk to Cognito directly, which might have been the impression that would have been given in the previous slide, but there are Lambdas in between. And you'd imagine for a login, the payload includes the username and password. That's passed on and back into Cognito. Cognito verifies those, generates a token, JWT token, as the response, and that finds its way all the way back to the client side. And then that token is used with all subsequent requests to this gateway. This gateway does need to obviously validate the token. And so there is a Lambda that performs that, which we call the authorizer. Now, I am missing one line. The authorizer does talk to Cognito, because clearly it's really Cognito that's doing the validation of the token. So there should be a connecting line there. And if Cognito is happy that the token is valid, then uh, the way we get the Lambda to tell Gateway that this token is okay is by means of an IAM policy. And the Lambda in the code that I will show you anyway, the Lambda kind of generates the IAM policy on the fly. And the policy just simply either says deny or allow the request to go through to the back end. So that's kind of the flow. And so we just want to look at, like, we know how to set up these guys. There's no difference between this gateway and this gateway. They're just standard RESTful gateways. But we do need to just maybe look at the lambdas and how do we create the Cognito user pool. Again, it's all fairly straightforward, to be honest. But so that's what we'll step our way through this kind of this application setup. Now, just for test purposes, I've got two simple lambdas here at the back end. One which does require user authentication before it can be accessed. The other one which does not. So there's a public one and a protected one. Yeah. So straight into code. This is just an excerpt from our CDK stack, and this is how we create a user pool. Nothing terribly exciting there. So user pool is another L2 construct. Just in terms of some of the configuration of it, we're telling it here that we expect we're definitely going to have username and email as attributes of a user. They will be stored in Cognito's data store. You could specify other attributes here. That's okay. Okay, we're just saying here that we're allowing the user to how does it put it, to self register, self sign up, yeah, self register. That's all right as well. We'll just have a simple endpoint for registration. And what's the last one? Our removal policy. Again, that's a bit like a database. When we destroy our stack, do we want the user pool to stay there or be destroyed? Now, in production environment, you would presumably want to hold on to the user pool. But in development mode, we're saying we want the user pool to be destroyed. Now, our lambdas are going to be talking to the Cognito, and obviously it needs to indicate what user pool it's focused on. Now, lambdas don't kind of talk to the user pools. What you need to do is create a client for a user pool, and then it's the client that the Lambda uses. So the client is linked to the user pool. And so we just need to generate a client, and that's what we're doing here. There are different authentication processes that you can have, or procedures that you can have, right? There is a built-in one, and that's the one that we're going to use, the kind of conventional user password authentication procedure. Okay. So we just do need to indicate that when we're creating our client. So that's all that there is to it, really. And when you deploy the stack, then you go into Cognito, and I've deployed the stack already. So if I go into my Cognito, and you can see here on the left, like, we have user pools and identity pools. So it's user pools that we're concerned with. And here's the user pool that was created. And if I want to see all the users in the user pool, currently there are none. That's straightforward enough. back to here. Now, if I go back to here, so we're going to have two gateways and some lambdas here and two lambdas here. So this screen is just showing you some stuff from the application that we're going to be looking at. So here's in my Lambda folders. Oh, no, sorry, no. What I'm showing you here, sorry. What I'm showing you here is from the authentication API. Sorry, can I go back again? From here on in now, I'll refer to this as the auth API and this as the app API. Okay. So the auth API, these are the endpoints that I've defined for it. Uh, I've decided, look, there's going to be a top level, kind of a root level endpoint called auth, and then off of that there are going to be various ones. There's going to be a sign up, and you know they're all for confirm sign up, log in, log out. Okay, so they're the endpoints of my auth API. These are the endpoints of my app API. And again, it's only kind of a dummy one. There's just two endpoints, and the names are kind of reflecting the nature of them. One is a protected endpoint, the other is a public endpoint. Down here, I'm showing you, so there are lambdas. Essentially, there obviously needs to be a lambda behind each of these endpoints, and that's what I'm showing you down here. And the names of the lambdas are self-explanatory. There is a lambda called authorizer, and that lambda is the one that validates a JWT token. So maybe if I flip over to VS Code. Okay, now this project you'll essentially build up in this week's lab. And I give you all the code, obviously, so it's a fairly straightforward lab to just run your way through it. What I do want to just talk a little bit about for a second, and it's not specific to Cognito now at all, but in general, up to now we've had just one file inside in the lib folder, which we kind of call the stack file, and that's where we put all our CDK code. But the stack file can get quite big, as you might imagine, for bigger applications. So rather than having one very long stack file, which is just not very kind of readable, we can take logical chunks of it out and put them into separate files. Now, the separate files are essentially L2 constructs that we're defining for ourselves. So you can define your own custom L2 constructs. You might remember we said there were L1, L2, and L3 constructs. There are lots of L2 constructs that come with the CDK framework, and we've been using lots of them up to now. But you can also just define your own, and it's not a big deal really to do it. And so what I've decided is I've decided to have two of my own custom L2 constructs. One, and you can kind of guess from the name, one construct is specifically concerned with creating the app API section, if you like, and its backend, its lambdas. The second construct is concerned with creating all the infrastructure for my authentication API and its backend. And the user pool is actually going to be defined in the stack file itself, because both of these constructs actually need to know about the user pool because they both communicate with the user pool. So if I look at the stack file, so look, it's a stack file, and here's where my code for creating the user pool, which we've talked about already. Sorry, here. And I'm creating my client, which I've talked about already. Now, that's fine. I'm also getting the ID of the user pool and the ID of the client. That's what the lambdas actually need in order to communicate with Cognito. They need to tell Cognito both the ID of the user pool and the ID of the client, because the user pool may have many clients associated with it. And here is where I'm creating an instance of one of my custom constructs. In this case, it's the auth API. And here I'm creating an instance of my second custom construct, the app API. And that's the end of my stack file. Now, these are my own L2 constructs. But if you remember, all L2 constructs have the exact same signature, which is the first parameter has to be the scope parameter. And sorry, this is my L2 construct. The first parameter is the scope parameter, which is always this. The second parameter is kind of a string identifier for your construct. So it's an arbitrary thing. And the third parameter is what we call the props object for your L2 construct. So we need a props object for our custom L2 construct as well. And we have to define the shape of this props object, the shape of the props object for the L2 constructs that come with the CDK. They're defined within the CDK type declaration files themselves. And we've kind of looked at a little bit briefly at one or two of those. So now if I look at one of my constructs, if I take the auth construct, and all a construct is a class that extends the construct type, surprise, surprise, instead of the stack type. Here is what I've just decided to define so my construct in terms of its kind of constructor. Where's the constructor? Here's the constructor here. As I've just been saying, the constructor of any construct is always three parameters: scope, ID, and the props object. So I have to define the props object in this case, and that's what I'm doing up here. Okay, so it's a simple enough props shape in my case. I'm just passing down some user pool stuff, but this is completely up to you as to what you want the structure of the props object for your custom construct to be. That's fine. So the only reason I have some private properties here is because it's just specific to this construct. Is I have a private function. Like if I go down to here, I just have a private function. Sorry, a private method within this class, and I want that method to have access to some values. Okay. Now I could pass them down as parameters, but I've just decided to make them private properties. And so within that private method below, I can access these class level private properties. That's all that's going on there. So there's nothing special about them. And I suppose we could look at, so this is the auth API custom construct of mine. And so we could just quickly step through it. What am I doing here? I'm just extracting some values from the props object that's passed into me, that being the user pool ID and the pool client ID. Then, lo and behold, I'm creating my RESTful API. I'm sure you're following along with me now, but this line is essentially creating this guy here. It's just standard RESTful API. Create my RESTful API. Set up, declare the root resource, which was I've just decided will be auth. So I want all of my endpoints to begin with auth. just arbitrary decision. And uh, rather than coding the individual detail of the endpoints for this API, in other words, the resource name, the method, the lambdas, because there's a lot of repetition going on, I've decided to put that repeating code into a local private method, which was the method I just showed you there a minute ago. So what I'm doing here is I'm calling that method a number of times, here, here, here. I'm calling it essentially for each endpoint, the sign up endpoint, the confirm sign up endpoint, the sign in endpoint, the sign out endpoint. Okay, so you can look at the detail later on, but that's all that's going on there. And in the actual method itself, what is it doing? It's actually creating the individual endpoints, extending the auth endpoint, which is kind of the root endpoint, adding a resource or an endpoint to my API. Here I'm just creating the Lambda function behind it. Oh, sorry, am I doing that? Yeah. Thought I had something else going on there. No, okay. I'm just creating the Lambda, and each Lambda is passed in as environment variables, the user pool ID and the client ID. So that's being passed around a lot, as well as the region. And then we've seen this kind of stuff before. Here I'm adding on what am I doing here? Oh, well, okay, I'm just creating a Lambda integration. I didn't have to create that. I could have embedded that. Sorry, no, just give me one sec. Oh no, sorry, I'm adding on the method to my endpoint, get, put, post, delete, whatever it is. And the method is passed in as an argument to this private function. And it's a Lambda integration as they always are. So, there's nothing new going on there, even though I've just slightly restructured how I've coded it. The other construct is similar, the app API custom construct. It's responsible for creating this resource and this Lambda and the two Lambdas over here. Okay, so I won't step through that for now anyway. But it's very similar to the other constructs. So both of these constructs are quite similar in terms of what they're doing. And that's not surprising because, they're both dealing with similar resources, API gateways, Lambdas. Right. Next is maybe to look at some of the individual endpoints of the auth API. And a logical place to start is with the sign up endpoint. Now, because of the type of user pool that I've created, a user pool that's based on user password kind of authentication method, then when I send a request to the sign up endpoint, I have to specify my preferred username, password, and an email because I did say in the user pool that I created that I want to store users' emails as well in the user pool database. So all this screenshot is showing you is just the Postman screenshot. So maybe if I just do that, if I just actually, so I've deployed my stack already, and I've shown you the user pool created. So if I go through a sign up, so if I go over to Postman, I've created a Cognito collection for myself for convenience. And that collection, I've defined some variables at the collection level. And these are the URLs of the two API gateways, okay, which I got when I deployed my stack. So I've set those up already. They're just the URLs of the endpoints, as I said. We can ignore this one for a second. So here's my prepared sign up request. So this is the structure of the payload. So I'm trying to sign up as user A. That's my password and that's my email. And it's a post request to this endpoint. So again, the endpoint starts with /auth and /sign up. And that was all based on the CDK code that I've just skimmed over there. So I do a send. And it looks like I got back a successful, getting a 200 response back. Now, if I flip over to my user pool, and if I do a refresh, I think on this page. Okay, so there's my user. Initially, a user is, they haven't verified their email. So what actually happens behind the scenes is when you sign up, Cognito will send an email to the email address that you provided in the sign up payload. And I provided my Gmail. Also, we can see over here that this user hasn't confirmed their registration yet. Okay. And so if I go over to my email, uh, I should have gotten an email, but I haven't. Okay, there's the email. And so Cognito sent the email. It actually used a service called an SES service. And what it emails to you is a code. There's my code. And the way it works is I now need to confirm my email. And I do that by sending a request to the confirmation endpoint in my auth API. Again, when you go back and look at the code in the lab, this is just another Lambda that will be triggered. So that particular endpoint, its URL is /auth/confirm signup. It's a post request. This is the payload that I need to send. So I need to send my username and the code that was sent to me, which is this code. When I click send now, that will go to my auth API. The auth API will send it to the confirm signup Lambda. Lambda will talk to Cognito. We'll have a look at the code in a moment. And Cognito will check that everything is okay. So I get back a successful message. And if I now look at my user entry in the user pool, do a refresh. So we can now see that the email has been confirmed and the user is now confirmed, like as they've um, completed the registration process, if you like. Now you can have a different kind of confirmation flow and registration flow if you want to. You can have your own custom registration flow. You have to code that, obviously. This is just the default one that comes with Cognito user pools. So what's actually happening behind the scenes? There are some lambdas being triggered. We can understand the flow kind of at this level up here. First request went to the gateway. it sent that request on to a specific Lambda that deals with sign up, talked to Cognito. We got a successful response back, but Cognito also sent an email out to my email account. And then I sent a second request, which was the confirmation request. That was forwarded on by Gateway to a second Lambda, and that Lambda communicated with Cognito again. And eventually Cognito updated my account entry in the user pool to say that the user has confirmed their registration, if you like. Now, the actual Lambdas in here, that's probably the only thing that we would need to just briefly look at because there's nothing special going on here. If we look at the login, the sign up and the confirmation sign up Lambdas, and they're quite brief, really. So here we go. At the very beginning, in the kind of initialization part of the sign up Lambda, I'm essentially creating a connection to Cognito. This is just a connection to Cognito, we don't connect to a Cognito pool as such. So we're creating our connection to Cognito. And then in the actual handler itself, okay, all we're doing here is just extracting the payload properties from the event object. We've seen that before when we were doing our database stuff. What's nice is, so Cognito has an SDK, just like DynamoDB has an SDK, and all of the other services have their own SDK. And what's nice is the design of pretty much all of the SDKs that I've seen anyway, they all follow the same kind of programming style. If you remember with DynamoDB, we had to create a command object. So in the case of DynamoDB, it might be a query command or a get command or a scan command object. And then we send that object kind of essentially to the whatever the backend service is, DynamoDB or Cognito in this case. Well, that same kind of command oriented style is used by the Cognito SDK as well. So the specifics in this case are we're creating a sign up command instance. Here this is just the properties of, here we're creating the actual sign up command instance. And it just takes one argument, and this is the argument, which I'm just setting up here. So, we're specifying the user pool client ID, the username and password that was entered by the user, and the email address as well. Okay, and we send that to Cognito. Client is our connection to Cognito. So within this, like as I said at the outset, you specify the user pool client ID, and that's enough for Cognito to work out which user pool it should be dealing with. Although I thought we specified the pool as well. Looks like we don't. No, we don't. Okay. And, the usual stuff then. I'm just sending the response. Well, now, okay, maybe the implementation of this is a tiny bit weak in that I should really have checked the response to make sure it's not a failed response. I'm kind of assuming it's a valid one. So that's not great really, but, and then I'm returning my response back to the web API client, if you like. Yeah, the confirmation sign up, I've stepped through that. So if we fast forward to the code, it has the same kind of flow to it. Yeah, get your Cognito connection, extract whatever parts of the request from the client. In this case, I need to extract the username and the code. And then in the case of a confirmation request to Cognito, the command is called a confirm sign up command. Again, I'm just creating the parameters for that. And I'm sending it to the to the Cognito service. Exact same flow of control. Again, I should really be have some sort of condition test here to make sure that the res is okay. Yeah, a mistake I was made initially when I was playing around with this stuff was I was leaving out the await sometimes by accident, and you don't get an actual, the lambda doesn't throw any exception because you don't have a weight there. It simply just falls through. Uh, so it's not an easy one to debug. Like even though I have got a catch clause down here, the catch clause isn't triggered. It just falls right through and you get a response. You get a 200 response back. But when you go looking at the user pool, you find that nothing has changed in it. Okay, so kind of a 101 mistake admittedly, but if you do simply leave out that await, then uh, it can be tricky to debug it. That's confirmation. So our sign up completed. The next logical thing that we would want to do is to log in. And maybe I'll just demo the login first. Not that it's that exciting, but so for my particular case, I want to log in as user A. Yeah, sign in. And I'll just click go. Now, what I'm getting back in the response is now I've decided to include. Sorry, what I'm getting back in the response is a JWT token if it's a valid login, and I just have included the token in the actual response body, which is probably not a great thing to do from a security point of view, but I'm just doing it because it's illustration purposes. So what we're seeing here is the JWT token that was generated by Cognito for us. I'm also returning a better way to communicate the token back to the user is to include it as a cookie. And so in Postman, you can see what cookies were included in the response. If you just go here, you've probably done this before. And if I click on token, so here's the JWT token. Now I'm just going to grab it because I'm going to use that token when I want to send requests to my, excuse me, to my actual backend functionality. So if I just grab this, uh, get out of here. Oh yeah, right now. So that's what this variable is about. So I'll set my, okay, so I have my token now. And if we just look at the Lambda that was triggered to deal with the login request, again, there's nothing terribly unusual going on, I don't think. Same flow again, connect to your Cognito client, extract the necessary data that the user sent in the login request from the event object. And okay, the command, in this case, the Cognito, or sorry, the SDK command is called initiate auth command. So that's what we're setting up here. Again, we're always including the user pool ID, uh, the client user pool ID. You do have to, which I kind of found unusual, you do have to tell Cognito the type of user authentication style that's being used, if you like, even though we indicated that when we created the user pool. But we told, if you remember, when we created the user pool, we indicated what type of authentication procedure was going to be used, and we used the default one that's provided by Cognito, even though you can define your own custom one. We're kind of doing the same thing here. We're telling it the authentication, so it's a bit of repetition, but anyway, we have to accept it. And then I'm passing in the actual username and password, and I'm sending that request to creating an instance of the command object, and I'm sending it to Cognito. And what it returns back is, okay, it returns back an object, but we have to dig into that object to extract the actual token. So that's what I'm showing you here. So there's this property within the response, and that property has a key called that. And that's where our actual token, or JWT token, is contained. And here's where I'm returning the response back. And as I showed you, I am including the token in the actual response body here. But as you probably know, this is how you can include cookies in the response using that set cookie HTTP response header. And generally, as you know, generally you can include many cookies in the response. And a cookie, as I'm sure you also know, a cookie is just a key value pair. So I've decided to call the key token, and the value is the actual token string. And that's what's going on here. But generally there could be many cookies returned. Okay, that's that. Next, they're just screenshots from Postman, so don't need to talk over that or that. All I'm showing you here is, I'm sure you know that a token is just an encrypted piece of data, and if you decrypt a JWT token, what do you actually get? Now you can decode, sorry, decrypt, decode probably mean the same thing. If you decrypt a JWT token, you get a JSON structure, and there is some useful information inside in that JSON structure, and that's what I'm showing you on the right here. This is just a screenshot from a website where you can manually paste in a token, and it'll tell you what information is contained within that token. And we could do that if we go back to Postman, and if I just grab the token that I have here, which I just copied in, and if I go to that website, which is just called jwt.io, I think. Here it is here. So I'll just clear that. So I'm pasting in. Now I do have to take out parts of it because what I'm really copying here is the cookie. It's not the cookie, it's just the token itself. So I need to get rid of this part at the beginning of the cookie. And there's also a bit at the end that I need to get rid of, which is all of this. Okay, so that's my full JWT token, and you can see here on the right the decoded or decrypted form of that token. And, if we see, where is it? Oh yeah, you see here, I can actually find the username of the person that signed in or logged in. So this property called cognito.username uh, contains that. And I think their email address, maybe not, no, their email address isn't there, but that's okay. So that can be useful, if you want to know, maybe some other Lambda within your application wants to know, well, who actually sent the request. This would come in now uh, come into play when the user tries to access some piece of functionality within your application. And maybe you want to know who is actually trying to access the functionality. So you can get it from the token, is essentially what I'm saying. Okay, I'm manually decoding the token here, but you can do it programmatically as well. And we actually have to do that. Do we do that? I think we do that in the code. I'm not sure. We'll come on to it. So I have looked at the main lambdas up here, and now if we switch our focus to down here, so the client now has a JWT token, and they can try and access protected parts of the backend functionality of the application. And so this is the Lambda that we need to look at next, the one that actually authorizes access to the backend or not. So what are we looking at here? Okay, this is an excerpt. Sorry, now if I go back again. Uh, what we need to look at first of all is how we uh, indicate in our CDK code for this web API, how we indicate that there is this authorizer lambda, because its role is very different from these kind of lambdas up here. These lambdas are just normally backend lambdas, as we might call them, and we have lambdas over here as well, which are traditional backend lambdas. But this lambda has a very specific role, and we need to indicate that in our kind of configuration of this RESTful web API. And that's what I'm showing you here. Okay, so first of all, I'm just creating the RESTful web API. I am just creating some endpoints, which I've just called, one is protected and one is called root. So there are my two endpoints. Here, I'm just creating the two lambdas that will be the backend for these endpoints. I've collapsed the detail because they're not interesting. And thirdly, then, is my authorizer lambda. Now, it's just a lambda, okay, number one. So there is nothing, I've collapsed the detail of this lambda as well because, as I said, it's just another lambda. But this is where you kind of tell API Gateway that this lambda has a special role. So what you've got to do is create, what does it call it, a request authorizer. So this is just another L2 resource in a way. And within the props for this L2 resource, you're pointing at the function. This is here referring to this lambda up here. And what else do we indicate? Oh yeah, we're saying here we have to indicate where within a user request, within a HTTP request, where will the JWT token be, where will it reside? Because this guy needs to extract the JWT token from the request that comes in and ask Cognito to validate it. So we need to indicate where within the HTTP request is the JWT token located. And if you look across, like I'm telling it, look, it's in the cookies. You'll find it in the cookies header. What's the rest? Okay, I'm just telling it don't do any caching of cookies. So this is a what's we're calling a request authorizer resource. And the final piece of the jigsaw then is down here, we need to indicate which of our application backends uses this authorizer. In other words, which of these application backends are protected and which of them are private or are public. So I've just decided that the protected Lambda function is going to be or is going to require authentication. So I'm just adding my method to my endpoint. Protected here is this guy up here. Protected resource, adding the method. It just happens to be a get method, but it could be any method. Here's my Lambda integration. Here I'm specifying the Lambda function, this guy up here. And this is how we indicate that this particular endpoint needs to use the authorizer to do its thing. Here's the other endpoint, and it doesn't have anything special associated with it. It just has a normal Lambda integration. There's none of this stuff being specified. Therefore, this endpoint is a public endpoint. There won't be any validation of the JWT token. Whether it's there or not, it's going to ignore it anyway. Now, what's going on here? Oh, yeah. So maybe if we just try and exercise it first. Sorry, if I go back to here. So what I'm going to do now is send a request to this gateway. And the purpose of it is to try and access the protected endpoint over here. Yeah. Now, all of these requests here, like if we just look at this one, it's using the auth API variable that we set up. Clearly, this one is using the app API variable, which contains the URL of the lower API gateway in my diagram. And the endpoint path name is just slash protected. Nothing special there. It's going to be a GET request. Now, where do we include the cookie, or sorry, the token? And the token is going to be in the cookie request header. So the token is returned back to me when I log in, is returned as a cookie, and I'm also sending it as a cookie in my requests. So I need to enable the cookie header. Okay, what we're looking at here are the request headers that we want to include in our request. So our cookie header is included, and I just simply set it to the variable that I declared at the collection level. JWT token has to be a key value pair because that's what a cookie is. And if I go back to here, here's my JWT token, and it is a key value pair. The key is token, and the value is the actual token itself, or the JWT token. Now, just specific to Postman, there are a few other headers. When I played around with this, there were two other headers that I had to, HTTP headers that I had to include in the request. Otherwise, it just didn't work for me. But this is kind of Postman specific. So the host header, and I think this one is also being used. But you'll find like if you disable those, then the request actually won't get processed properly. So other than that, it's all fairly predictable. Uh, how do I know whether it's going to work or not? Well, in my case anyway, this is the Lambda. This guy. And so it's just going to send back a message that says this, right? Yeah, we can ignore this stuff for the moment. So let's go send. Oh yeah. Okay, so that looks like it worked for me. And to prove that it does work, if I intentionally, well, obviously if I leave out the cookie, and if I send it a bad cook or a bad token, so if I go into here and just intentionally mess up the token, so I'll just get rid of the last character. Oh yeah, well, sorry, yeah, the token actually ends here. The last character is a W, lowercase. And try and send again. Okay, so it's telling me there's something wrong with the token. So that all seems to work. So that's telling me that the authorizer is doing its thing. Now, the authorizer itself is the only remaining part. And what I'm showing you on this slide here is a kind of a narrative description of the procedure that's performed by the authorizer. So first of all, uh, it has to extract the cookie from the request, and within that cookie, it has to uh, just dig out the JWT token, and that's just code, right? Cookie generally, or in general, the HTTP request cookie header is a string, and that string uh, generically consists of a number of key value pairs for each cookie that we want to include in the request. And the key value pairs are separated by colon. So really, just needs to, first of all, parse the entire cookie header, uh, parse it based on the colon character, and then within each entry, it needs to parse it based on the equal sign, because a cookie is a key equals value kind of string. So it just needs to do that, right? And what I've just decided to do is to store all of the cookies in a map, um, standard kind of map data structure, where the keys of the map are the cookie keys and the values are the cookie values. Now, it turns out that I'm only sending one cookie, so it's a bit of overkill, but it's a generic kind of solution. So after step one has been completed, I now have a map data structure, and hopefully within that data structure, there is a key called token, and the value will be the actual JWT token that's included in the request. So find the token key in the map. If it isn't there, then you might remember I said, if I go back to here to the diagram, uh, the way this works is it needs to tell API Gateway whether to allow the request to go through or not. And we do that by means of IAM policies. So it needs to generate the appropriate policy JSON structure, and then API Gateway uses that to complete the request. So that's what I'm saying here, right? If there's no token at all in the request, then return an IAM policy that indicates deny the request. And we saw that was actually happening when I took out the cookie in my request. Uh, Otherwise, there is a token entry. And so I just need to, and I need to verify the actual token itself. And I get Cognito to do that for me. So Cognito kind of does this stuff, but my authorizer needs to ask it to do it. And it will respond saying either, yes, the JWT token is valid or not. And if it is successful, again, um, I generate an IAM policy on the fly. In this case, the policy will indicate to allow API gateway to forward the request on to the backend, else deny it. So that's the flow. The code, a lot of the code is boilerplate, but uh, if we just, here is the authorizer. And I also have I put some of the code into utility kind of functions. Again, I would like you to look at this yourselves. Just give a quick scan over it. I mean, I'm giving you all this code, and you will in fact reuse this code in the assignment, which I'll talk about probably next week. But just briefly to scan over it. Uh, Here I'm calling a local function. Now this function is actually defined in the utils file over here. And what that function does is it takes the HTTP request header value and parses it up and creates the map data structure, and it gives that back to me. So uh, this thing here now is going to be cookie map is just a data type that I've defined for myself, but it's essentially like an ordinary map data structure. I am checking to see if, well, hopefully there are some cookies. If they're not, then what am I doing? I am I've got another utility function that creates the IAM policy. We'll look at it in a second, but that's what it's doing here. It's creating an IAM policy, and I'm returning that policy with this extra kind of wrapping. I'm returning that back to, who am I returning it to? I'm returning it to API Gateway, because API Gateway has invoked this authorizer function, this authorizer lambda. Otherwise, there is cookies in there. The next thing we are doing is again, this is another utility function, but I'm sticking a wait in front of it because when we just look at this function in a moment, it is talking to Cognito. So that's why it's an asynchronous function call. And I am passing to this function the actual token key within my cookies. I did say that that key within the cookies, within the kind of map structure, that key its value will be the actual JWT token. So essentially this expression will bind to the full JWT token itself. And what else am I telling it? I'm passing my user pool ID, and I am passing the region. So unlike all of the other lambdas up to now, we're using the user pool client ID, but in this case, it's the user pool ID. Again, that's just dictated by Cognito. So, and based on how this verification utility function got on, I return an IAM policy, which is either going to allow or deny. Is that what's going on here? Well, okay, this is a nice kind of what am I doing? What's that operator called? Forgotten the name of that operator. It's just checking the what was returned by my function. And if it returned something out, I think it returns undefined if Cognito failed to validate the token. Otherwise, it returns a data structure. Yeah. So if this is something other than undefined, then allow the request to be passed on by API gateway. Otherwise, deny it. Otherwise, deny it. Yeah, and so what's left then is just these utility functions. Again, they're kind of boilerplate. The first one is the one that parses up the cookies, the cookie header into the map structure. That's what's going on in this function. Let me just check again. Yeah, the cookie map function. So you can look at that. This is oh, I'm wrong. Sorry, beg your pardon. This is the one. This is the function that parses up the cookies header string. Sorry, now I'm just checking it again. This is the one that does the verification, and you can see what we're actually doing is, there is that's an actual Cognito endpoint. Um, yeah, it's just this URL is just part of the Cognito service, and you can see it seems that you have to invoke a particular within a particular region. Like there are different endpoints incognito, even though endpoint we tend to associate with an API gateway, and that's Cognito is not an API gateway, but it has endpoints anyway, and it has endpoints for performing verification of tokens. It has other endpoints as well, but it looks like that endpoint is broken up into different regions. So I need to specify the region within this whole URL, and and where do I actually talk to? Oh yeah, here's where I talk to Cognito. I just make a kind of a raw HTTP request, really. I'm using the Axios library, which you're familiar with from last year. So this is kind of a raw HTTP request rather than um, any kind of higher level abstraction. This is the function that generates the IAM policy. And again, you can just take this as boilerplate, right? You're familiar with the structure of IAM policies from last year. So, and this policy is parameterized, but the only parameterized part of it is, well, okay, what I'm passing into this is the event. What do I mean by event? If I go back to here, so the user sends their request. As we know, when we talked about API gateway, it takes the HTTP request and it generates an event object, and it passes that on to up to now it was passing it on to lambdas that were kind of here, but it's now passing it on to this lambda here. And I'm just taking that event object and I'm passing it down to my utility function. Okay, so that's what I mean by event here. And effects. I think these are used uh, to parameterize the IAM policy. Just checking about this one. I've forgotten what that one is. Effect. Oh yeah, the effect will either be allow or deny. Okay, so this function needs to be told, should it generate a policy with the allow effect or the deny effect? Okay. Anyway, in the lab, you just build up this entire code base yourselves. And so as you build it up, um, you can pay a bit more detail, more attention to the Lambda specifics. I wouldn't get too overwhelmed by the authorizer. Certainly have a scan through it, but it works, so just use it. You'll be using it in the assignment, as I said. So you're free to just cut and paste it in, and I've already illustrated that it works, so there shouldn't be any issues, and you won't have to make any changes to it. Where are we on time? Doing well. Okay. I will pause for questions, but I'm not sure whether there are any. No. Right. So we've essentially built up this entire mini application for ourselves. Right, that's it. That's Cognito done. For what time is remaining, what I actually want to do is go back to some of the labs. So you'll remember he submitted this TypeScript lab. So I'm just going to briefly talk about that. I know it's a while ago now, but I just bring in my solution. So when I was correcting the TypeScript lab, what I did was I first of all looked at the commit log for your repo, and if there was a reasonable distribution of the workload other than in the last day or two, um, then I would look at the actual detail of your code. If there wasn't a reasonable distribution of the workload, I gave you 2 marks, and I did not look at your code. If there was a reasonable distribution, then what I did was I essentially just looked to see that you um, attempted the exercises. And in particular, I'm sure now you've forgotten what the exercises were, but I went into the functions file, and there you had to define a function called all older. And you can go back and watch this video if you want to. I'm not going to talk through the implementation, but my implementation of all older is where is here. All older, I'll just kind of remind you, all older was passed in an array of friends, and what it had to do was increment each friend's age property by 1. Okay, so I'm just mapping over the array of friends, and because I already had a function called older which deals with changing one friend's age, I'm calling older within the callback of the map. Okay, some people wrote this as a for loop. Um, some people actually took this code here and put it into the callback. I didn't necessarily take any marks away, for either of those. You definitely try and avoid using for loops as much as you can. You should use these higher order functions, map, filter, reduce, and there are many other higher order functions. You should get into the habit of using those when you're writing any code in any language, not just TypeScript, stroke JavaScript. So I looked at that, and then there was another exercise which asked you to implement and add interest to a friend, I think, wasn't it? So here's my add interest. And if you remember, the friend data type interest was an optional parameter. So we had to check, first of all, was there already an interest property in the friend that's being passed in here. We're passing in a friend instance into this function. So that's what's going on here. The ternary operator, sorry, I couldn't think of that name earlier on. So I'm just using the ternary operator. You could use a bog standard if statement if you want to, just to make sure that there is actually currently an interest property, because you can't, if you try to push onto the property and it didn't exist, well, you'd get a TypeScript compilation error anyway, because it's telling you, it would tell you this property is not mandatory. So you need to use the kind of question mark dot operator there, as you know. Where would you use it? You use it here, I think, actually. But here I'm just checking first of all to see does it exist or not. And if it doesn't, I create an empty array and assign it to that property. And then I can do the push. And I don't have to worry about whether the property exists or not. So that's that. I then looked at the aliases, type aliases, because there was a function called get, what did I call it? Get buddy list friends. And the idea there was, if you remember, you were passed in kind of a list of buddies, and a buddy was either a friend or a colleague. So you had to go through the list to find which of them are friends and put the friends object into another list and then return that list. Yeah. And so the trick, well, first of all, I did say you should use the reduce higher order function in your solution. Not many people did, but again, I didn't necessarily take marks out for that. People would have just written again a for loop. But the key part was you had to check, because our list of buddies could either be a friend object or a colleague object. You had to check which type it was. So pick a property that's unique to friend, which in our case was, I think, phone number was unique to friend. So here I'm checking to see is phone number in the buddy, and if it is, then we know it is a friend and we add that friend to the list. And finally, I looked at the util type function file, and I asked you to implement a method, a function that is passed in an array of friends and an array of colleagues, and it has to find kind of the intersection between them. But the purpose of the exercise was to define the return type, because the return type was neither a friend nor a colleague. It was kind of a mishmash of both of them. But you had to define this type, which I'm calling friend, colleague, friend and colleague. You can call it anything you want to. But I did say in the question that you should use other utility types to define this type. So in my case, what I did was I used the pick. So I picked some of the properties out of friend, and I picked properties out of colleague to give me this new type. I think it's probably fair to say a lot of people maybe uh, didn't pick up on what I was trying to get at there. You don't have to use pick, but you could have used some other ones as well. So that's what I did as part of correcting. As I said in the Slack message to you, there were 3 marks for your exercise solutions and 2 marks for the git log. But as I said at the outset, if your git log indicated that you only worked on it on the last day or two, it's crude correcting method, but I did specify in the lab spec that at the very beginning that you should try and spread the workload. I won't be as crude when I'm correcting assignments. I mean, this was worth 5%, and every percent is important, but that's the way I went about it anyway, for good or for ill. Going on to this lab, which one is it? This lab here. There was an exercise which I did think was straightforward, but I didn't get any questions about it. What was going on here now? So we have, sorry, let me try and remember. We're not using API gateway here now. We were just using function URLs, but sorry, let's go back to here. Am I looking at the right one? Sorry, it's not that exercise. It's here, sorry. Yeah, this exercise here. But just quickly to remind you, uh, so it involved using query string parameters in a request, and I have to remind myself now actually. Oh yeah. So the query string could have a movie ID key. It could also have a sorry, an actor name key, and it could have a role name key, if you remember. Yeah. And I mean, I gave you the code and the solution to this. So there were three keys initially: movie ID, either actor name or role name. And what it returned back, if you remember, was a cast item from the movie cast table. But then, as an exercise, I said, supposing there was another query string, right now, there was another query string option, which was, I just said it was this one here, facts equals true. And if that query string was included, if that query option was included, then not only should you return the movie cast item, you should also return the movie item from the movie table. Yeah. So how would you, it seems straightforward enough, you know, just check to see if is that query string, is that key value pair in the query string? If it is, then just send a GET request to DynamoDB to return the movie item and just add that into the response object that's returned back to the client side, which was AWS CLI in this case. But the kind of trick was, if I bring in the solution code, I'm going to assume, because I didn't get any questions about it, that people did it and they got it to work. But I'll show you a solution anyway. And you can watch back the video now if you need to understand fully what we're trying to get at here. So this was the Lambda function. And all of the code, I've given you all of this code. The bit that you had to add on is way down here. Okay, so I'm just checking here. Is the facts key within the query string? And is it set to true? If it is, then, I just send a GET request to DynamoDB. That's straightforward enough. The trick was, though, you have to kind of declare earlier on what is the shape of the response from this Lambda function. And we know about TypeScript that when you have an object structure, you can't kind of dynamically add other properties to that object structure. That's something I would have mentioned to you about TypeScript at the outset. Yeah, so if you've got an object structure, you cannot dynamically add other properties to it. So in this case, where that comes in is you kind of have to specify the structure of a response, which is what I'm doing here, and I'm allowing for the possibility that there might be a movie object in the response, as well as the cast member object, which is always going to be in the response. So I've done that there, and that's what allows me then to where do I do it? To build up this response object. Is that what I'm doing there? Yeah. And I'm adding in my movie details, which I've gotten from DynamoDB. So in summary, if you don't declare this structure, um, it won't work for you. You can't just suddenly go adding in another property into the response object when you didn't declare it previously. That's that. There's also a similar kind of exercise, I think, in this week's lab, but I won't cover that for now. Now, you cannot see this, but what I'm going to look at now and start talking about, but I'll go into more detail next week, is the first assignment. So this is very much a first draft, but I'll clarify it for next week. I'm going to skip over this stuff, but it's extremely important that you read through this when you eventually see the specification. And so at a very high level, what the assignment is to develop a RESTful web API, surprise, surprise, for a movies context, surprise, surprise. And there are various backends that I'm specifying. So the spec is very detailed, but there are opportunities for you to demonstrate your knowledge of. It's really a focus on AWS serverless rather than designing a skeleton application. I'm giving you the actual specification. You've just got to implement it. Let's see. And okay, this is, I may change the completion date. And it's what, 45%? That's okay. So I am specifying these particular endpoints for our web API. So this is straightforward enough. Get /movie/movie ID. That should return a movie. This one is straightforward enough as well. Get movies, movie ID/actors. That should return all actors in a movie. This returns, what does it return? A specific cast member in a movie. Not too exciting so far. There's also, our database is also going to have information about awards that a movie received or awards that an actor received, be that, Academy Award, BAFTA Award, Golden Globe Awards. But we're specifying what we're looking for here by means of a query string. I'll come back to that maybe some other time. I'm just going to give you a high-level view. We're going to be able to want to be able to support adding a movie to our database, deleting a movie, that's fine. And there may be one or two others that I will add on to this list. Okay, what's next? So when you're developing any type of application, certainly an application that has some sort of a database to it, at the design stage, you need to think about what are the different data types that pertain to your problem domain, as you know. And so the data types, and again, I'm giving you all of this, right? The data types that we're going to be dealing with are movies, and I'm specifying these are the properties of a movie. There is an actor data type. These are the properties of an actor. There's a cast data type. That's the properties. And there's an awards data type. All fairly standard. The thing about awards, though, is that it's the award ID is either a movie ID or an actor ID. And the rest is straightforward enough. Yeah. Now, something I wouldn't have mentioned in relation to DynamoDB is that, like, when we come from a relational database background, we think about a database as being comprised of many tables. And if it's a relational database, then um, there are relationships between those tables. And even maybe when you looked at non-relational database technology, e.g., MongoDB, it would also have been expressed in terms of having many collections. In the case of MongoDB, we don't call them tables, we call them collections, but having many different collections within your database. Now, DynamoDB actually suggests that you should only have one table in your DynamoDB database, but that table should store different types of items. Remember, an item is essentially a record. So our database, our Dynamo, and we're going to follow this, and I'm giving you the actual design for it. You know, if there was more of a database angle to this module, then I would tell you, come up with a single database design. But that doesn't apply to this module, so I'm giving you the design. So we're going to follow the single table kind of design principle. So we're going to be storing movies, actors, casts, and awards all inside a single table. That table is going to have a primary key, as all DynamoDB tables need to have. And in our case, the primary key is a composite primary key. So it's going to have a partition key and a sort key. But the because we're storing different data types, that means we need to have some way of distinguishing between a movie item and an actor item. Because a movie ID we said is a number, numeric value. So you could have a movie whose ID is 1234, and we could have an actor whose ID is 1234. And indeed, we could have an award. What did I say about award? Uh, an award. Oh yeah, that could either be an actor ID or a movie ID as well. Okay, but either way, like the partition key needs to somehow be able to indicate, well, is this an item? Is this an actor item or movie item or one of the other types? So what I've decided is, and this is a kind of classic way of approaching this, you use a prefix in the, so it's the partition key I'm talking about now. You use a prefix in the partition key value, which identifies the type of item that it is. And in my case, I'm going to use a prefix of M to indicate it's a movie item. Item, remember, is essentially a record. It's going to have the prefix A if it's an actor, C if it's a cast, and W if it's an award. Uh, so the partition key is going to begin with one of these characters, and the rest of the partition key will be the actual ID of the data entity itself. Movie ID, actor ID, etc. So you could have a partition key that is M1234, And the M means that it's going to be a movie item, a movie record. The actual ID of the movie is 1234. The partition key value is M1234. And the rest of the properties then are whatever are relevant properties for a movie, which I've told you what they are earlier on in the spec. And we know that DynamoDB, just like all other non-relational databases, is schemaless. So there's no problem having, apart from the primary key and the sort key, uh, the other properties or attributes of the items can be different for each item. Okay. Uh, Now, I'm actually going to stop here, but I'm just giving you kind of a high level introduction, and I'll drill. There's a little bit more that I need to show you. I suppose I could scan down to here. Like here are some examples of items that might appear in a table. So this might be one item in the table. So its partition key is M1234. Now, the sort key doesn't make any sense in this case, so I've decided that, and again, this is kind of classic DynamoDB design. The sort key is just going to be XXXX. It's a kind of default sort key. And then the rest are the attributes of a movie. So in my case, I had movie name, the date that the movie was released, and then a kind of overview of the movie, I think is what's next. That's kind of the overview, subset of the overview. Here's an example of an actor item. The partition key begins at A, so that must mean it's an actor. The actual actor's ID is, in this case, 6789. The sort key doesn't make any sense here. Kind of haven't explained why it doesn't, to be honest, but I'll do that next week. The actor's name, the actor's bio, and the last thing I think we said was the actor's date of birth, which is all the way down here, I guess. That's their date of birth. I'll leave it at this now. So the cast is the last thing we look at. This is a cast item or a cast record in my table. It begins with C. And I did say that the cast partition key begins with C and the rest is the movie ID. The sort key is the actor's ID. I gave that detail earlier on. I know I'm only running through it now, so you won't have remembered that. But so the sort key is meaningful here. It is the actor's ID. This is the character's name in the movie, and this is a description of the character's role. Is that all that's there? Yeah, that's all that's there. And then we've got an example of an award as well. So I'm going to leave it at that for now. So I know it may seem a little strange initially because we haven't seen single table but before, and I'm not asking you to design a single table. I'm giving you the actual detail of it. You just need to understand the detailed design when I eventually make this available to you, which will be next week. And I will give you ample time to complete this assignment, so time won't really be an issue. I haven't finished looking at the specification, but from what I've talked about so far, are there any initial questions? Probably aren't really because you haven't had a chance to absorb the stuff. No, what I'll try and do is, well, definitely will do, is I will make the assignment specification, the final version of it, available to you before next week's lecture, so that you can have a read down through it, and then you may have formulated some questions that you want to put to me. And that's what we will actually do in next week's lecture. So I'm not going to be covering any new material in next week's lecture. I've essentially finished the serverless part now. So we'll go back over the specification. You will have read it beforehand. And we can have a Q&A if you have any questions for me. Doesn't seem like you have any initial questions. That's okay. So I'm going to stop the lecture at this stage, and I'll talk to you in the labs next week. You have a Cognito lab that you need to work your way through, and you will be using that code in the assignment because there is an authentication and authorization part to this specification, which I haven't looked at with you. But you can essentially reuse all of the code from the Cognito lab, and I say that in the specification. And I don't think there's hardly any changes that you will need to make to it, although may need to think about that in more detail before next week. Right, I'm going to leave it at that, and I'll talk to you next week in the labs. Bye-bye.